Let's consider the graphs of some absolute value functions and just see what they look like. We're going to consider f of x, just absolute value x, the very simplest possible absolute value function. G of x is 2 times the absolute value of x minus 1. And h of x is kind of complicated. It's negative a half times the absolute value of x plus 1 plus 3. Right, and we're going to use our graphing calculator to examine the graphs of these things and just get an idea of what they look like. So here's my graphing calculator, which can do clever things with colors. And notice I have y1 set to give me a red graph, y2 set to give me a blue graph, and y3 set to give me a green graph. I'm going to graph f as y1, g as y2, and h as y3. So here's the question. How do I get my graphing calculator to give me an absolute value? Here's how. I'm going to hit the math key. When you hit the math key on your calculator, you should get a menu that looks like this. Now I don't want the math menu. I actually want the number menu. This does number computations. And you can see the very first choice on this list is ABS, which means absolute value. So I select that, and on my screen it actually gives me the 2 vertical absolute value bars. Depending on exactly which model of calculator you have, it might type the letters ABS and some parentheses for you. Either way, f is just absolute value x, so I'll just enter x inside the absolute value. All right, g. So for g, I will have 2 times, again, math, over 1 to select num, select abs, and inside the absolute value, x minus 1. And now for h, this is going to be a little trickier, negative 1/2. And now again, select. Negative 1/2 x plus 1, and then outside the absolute value, plus 3. If your calculator is typing the letters ABS and some parentheses, make sure that the plus 3 is outside of the parentheses. All right, let's get the graph. Here's the graph at standard zoom. And looking at this, there are some things I notice. I notice something they all have in common. They're all this kind of V shape. And except for the fact that they turn around at the V, they're straight lines, right? Now I want to see a good representation of how steep these are. So I'm going to select zoom. Number 5 is square. Just to get the x and y axes, they have the same scale. So here are my 3 graphs, again, showing those nice V points. And it looks like I can see what I'll need to do in order to graph an absolute value function. What will I need to do? Well, first I'm going to have to figure out where on the graph the point of that V goes. And then, because I see that some of these V's open upward and some of them open downward, some are steeper, some are shallower, but they're pretty much straight lines. I think if I can find one point on either side of the V, I should be in good shape. All right, let's draw some of these graphs. So we're going to tackle F first. So I'm going to bring back my graphing calculator, but I'm going to go in and I'm going to turn off y2, turn off y3, so that when I graph, I only see the graph of f. And my question now for the graph of f is, where is that v? I'm going to press the trace button to get a point on my graph, and I think I already see. Yeah, that bottom point where we turn around is 0, 0. And that's actually a point on the graph, so I'm going to go ahead and plot that. Now I need one point to either side. Right? So I'm going to just choose some values of x to plug in. I'm going to take, say, x equals -1 and x equals +1. So f of -1, absolute value -1 is +1. X is 1, absolute value 1 is also +1. So what points will be on my graph? I'll have x is -1, y is +1, and I'll have x is +1, y is +1. Okay, so I'll have this point, and I'll have this point. And now from here on, it's just straight lines. Right, my line extends up from the point of my v this way, and it extends up from the point of my v this way. Here it is. This is the graph of y equals f of x. Let's try this again. I've got g of x is 2 times the absolute value of x minus 1. Again, back to the calculator, but this time I'm going to turn off y1, which was f, and turn on y2, which was g. We'll graph again. Again, we want to find the point of this v, so we'll hit trace and slide along until we seem to turn around. Well, it's somewhere in here, isn't it? Somewhere around x is 9 point something. You know, it looks an awful lot like that's going to happen at x equals 1. Let's see if we can get some confirmation for that. This is the table of values for this function. Yeah, it looks like it goes down steadily, hits 1 and turns round, and comes back up, right? We can look at some more negative numbers. Yeah. So here we think the point of the v is at x equals 1, y equals 0. And now again, we're going to want some points on either side. I'll take maybe 1 less than 1, so x is 0, and 1 more than 1, so x is 2. G of 0 is 2 times the absolute value -1. That's 2 times +1, so it's 2. That gives me the point 0, 2. X equals 2. That's 2 times the absolute value, 2 minus 1. 2 minus 1 is just 1. 2 times 1 is 2 again. So that gives me the point 2, 2. Plotting my 3 points. Here's 1, 0. Here's 0, 2. Here's 2, 2. And now I'm ready to draw. Start at the point, go up this way, start at the point, go up this way. Finally, let's do h. Again, back to the calculator, and I'm going to now turn off y2 and turn on y3, graph again, and trace to see if I can find the point. Okay, it looks again that where it turns round is somewhere around -1. I'm going to hit second table and look at the table. It really does, doesn't it? It goes up to 3 and then turns around and comes down again. I think that my point is at -1, 3. And now it occurs to me that since I'm already in this table on my calculator, I might as well use this to get some other points as well. So I could pick x is -2, y is 2.5, but I think I'd rather pick x is -3, y is 2. Why? Because I like graphing integers. Then let's see. Other side, maybe x is 1, y is 2. So my points are going to be x is -1, y is 3. X is -3, y is 2. X is 1, y is 2. Right, we see that the V is going to open downward. Get the ruler, fill in the lines, get the ruler, fill in the lines. Going back to my graphing calculator and turning all 3 graphs on again. This picture really does look just like this picture, doesn't it? So we haven't missed any important details. We really do just need to figure out where the V has its point and then find any 2 points, one on either side of the V. So in the next video, we're going to talk about how to figure out where the V has its point.